At this point, I would like to introduce to you David Cohen. He's the manager of codes and standards at the Northwest Energy Efficiency Alliance. He has worked in the energy efficiency area for almost 20 years as an evaluator, planner, and an implementer. His current responsibilities include the adoption of more stringent energy codes in the 4 Northwest states and ensuring high compliance rates with those codes after they're adopted. He has lived here in Portland for 15 years. David Cohen.
Thank you, Sean. Hello, everybody. Thank you for coming to Portland. I want to start by actually making that an official thank you to, I don't know if Gene Boleyn's in the room or not. Don't think, where is he? Thank you for approving Portland as the site for the conference. It was great. I did lobby, and then thank you secondarily to Diane and Terry and Rose and the other P&L staff for making it happen once we got that approval. It's great to have it here in my hometown, and I hope you all are enjoying it. I'm not going to apologize for the weather because I can't control it, but I apologize. I'm going to start by talking about the format here for a little bit. So this is the future of energy codes. I'm going to talk for about the first third, a little less, and then there's going to be a moderated discussion. Sean is going to lead a moderated discussion. The reason we ended up doing it like this was, I think given the breadth and just many possible ways you could approach this topic, I wanted to lay out a couple kind of stones we could refer to. It doesn't mean if you don't hear something that you think is important that you shouldn't say it afterwards. I don't mean that I have to guide the discussion, but I just want to throw a bunch of stuff out there and then we can move forward with this. The idea is that this is the first of what are hopefully many discussions at the national level that'll move us onwards. So, that being said, we're going to set the stage here. The current development cycle is over. The 2012 IECC is 30% more stringent than the 2006 version for both commercial and residential. ASHRAE 90.1 2010 is done. It is 30% more stringent than 2004. All of the states that don't have the IECC are at least as good as those, if not better. Now what? I've talked to a lot of people over the last year as we've gone through the IECC development process, and I think it was unanimous that if we want to get past 30%, it's going to take some. We've kind of squeezed everything out of the current system that we can squeeze out. Doesn't mean you can't keep going, but we're going to have to shake things up a little bit. So again, that's the purpose of this, is to start a discussion there and to get your opinions as well as my own out there. Just as a forewarning, I'm going to purposely overstate some things. In part, that's just because I think it's a good way to get a discussion going. You can react to me. And in part because, I don't know about you, but I just don't get that many opportunities to say kind of unfounded, indefensible things in front of a lot of people, and I don't plan to pass up this opportunity. So usually there's consequences for things like that. All right, I'm going to talk a little bit about sort of policy level things, then code strategies, and then a little bit on enforcement. That's the framework here. So, terms of policy, there's a couple things we got to get in place. First, this is going to sound obvious, but we need to define the goal, we need to set a timeline, and then we need to figure out what kind of resources we need to get there. This is basic project management. One of the beauties of the 2030 challenge is, for the first time, somebody actually threw out something concrete. The year is 2030. We're going to do it in five steps of 10% each. They didn't talk at all about the resources required, but at least they got a couple things. But this is basic project management. There's no way we're going to get national coherence and a national national unanimity about how we're going to move forward until we come to agreement on that. So it's a prerequisite. Second, codes do not exist in a vacuum. So you need to support the codes with research and development. You need to link the research and development to voluntary programs like utility incentive programs or things that nonprofits run. You need to link those to some sort of stretch code so that people know what's coming next. And then you'll need to link those to the mandatory codes. You need to give people lots of warning so that there's market predictability, so that prices can come down sooner rather than later. If everybody knows that something's going to become a commodity item, they'll start lowering the price. Right now, most of the time, you don't know what's happening until 6 months before you adopt the code, and then there's all this confusion. You know, you're about to see it when we start adopting the 2009 all over the country. We got to get over that. Third, this has been discussed a couple times, we got to get over the NACA, the equipment efficiencies. That's a huge barrier to building energy efficiency. I'm hopeful that it's going to get resolved in the next couple of years, but we're not getting far without it. And finally, we need to deal with incremental costs. So 30%, which is where we got to today, I made up this chart, okay? So I'm not saying it's database, but I can't tell you how many people I've talked about that say this is more or less it. So what you got is the first 30% that we're kind of getting this cycle, it's relatively cheap. You still had a bunch of development and construction people saying it was a lot, but there was a good argument that it wasn't that much money, so just deal with it and the savings are worth it. When we start talking about going to 50%, 70, 80%, those incremental costs are very real and they get very large. And there is no way from a policy point of view we're going to get there unless we somehow figure out, I don't know, transfer payments, subsidies, taxes, something's going to have to give. I personally have no problem at all pushing money to the other side of the table because you got to think about this in terms of societal benefits. I've been sort of as an observer involved with some of the standards appliances, the US DOE standard setting rules, talking about like insanity, $5 billion worth of societal benefits, and there's a $200 million hit to the industry, and they don't approve it. Like, just give them the $200 million. What's the problem? Look what you could get out of it. So we're going to hit that in code soon, so we need to figure out how to deal with it. All right, we're going to move on now. These are 4 basic strategies to get beyond 30%. They are not mutually exclusive. They're certainly not the only ones, and they're certainly not original to me. I'm, stealing from anybody I can. Back.
100% net zero.
100% net zero, and I purposefully made that go through the roof, that line. That's photovoltaics on the outside, right? So it's expensive stuff. All right. First obvious important one, whoops, is to increase the scope of regulation. These are all the things that determine building energy use. So we cover, the yeses and nos and somes are what's covered under existing codes and regulations. So we do a pretty reasonable job on design and construction, both new and new and existing. Commissioning is in some codes. People are trying to push it into the ICC. That'll be nice. Nothing for existing. And then you got to go all the way down to plug loads, which is the federal appliance standards. But I don't care how well designed your building is. I don't care how well constructed it is. If you don't deal with operations and maintenance and occupant behavior and everything else on there, it's going to use a ton of energy. So at some point, we've got to increase the regulatory structure. And I'll talk a little bit at the end. I mean, obviously, that's not going to happen the way the current regulatory structure is set up. And that's my point, right? We're going to have to change the system a little bit. You can't, this is kind of one of my pet peeves. People say, I'm going to build a zero energy building. Like, no, you're not. You're going to build something that has the potential to be zero energy if all these other things are covered. So we got to get to that. All right, second, testing and measurement. So first, I need to differentiate. Testing, I do not mean the performance approach, which is simulation modeling. Modeling is bad. I have a slide to support this. So, now that I've proven my point, I'm not going to go into a big theoretical discussion on this. I'm just going to ask you to do a little experiment. For those of you who know modelers, pick any 3 or 5, however many you know, take them in a room individually, and ask them if they think the other ones do a good job modeling. Those of you who have hung out with modelers know what the answer to that will be, right? If by some miracle they all say, oh yeah, they're all totally competent, give them the specs for a fairly simple building. Have them run their model and look at the answers. There'll be a huge spread. This isn't a knock, actually, believe it or not, on modelers. Well, it is, but I actually respect them a lot. The people who I respect the most are the really good ones who understand the limitations of models. Why I'm making a big point out of this is we do not want to use this as a main path. I said something good about the 2030 challenge. One thing I'm really frustrated about is they put out a white paper saying that the way to cut energy use through codes is just go performance with everything. Whack it in half, you're done. We do not want thousands of people who know nothing about modeling running models and then handing it to thousands of building officials who know nothing about modeling. You're not going to get much out of this. You're going to be very unhappy. So we want to stay away from that. If you have to do it, I'm sorry, you got to kind of take the California approach. You want to invest millions of dollars into an infrastructure, you want to train people, you want to get a third party set up, I'm with you. And even the rest of the country, you have a really sophisticated large building, you've got the $25,000 to pay somebody who knows what they're doing, preferably certified through, Ron Jarmigan was saying they're setting up some sort of certification. I'm with you, but please, we need to stay away from this idea that, you know, Joe is going to run a model and hand it to a building official because that's what the code says to do or is encouraging him to do. All right. So what I actually did want to talk about here, I don't want to forget that, this testing and measurement, the idea is this gets you what you really want. We want to know how these buildings perform. So ideally, you would do full building commissioning. And for those of you who don't know, commissioning is a quality assurance process that makes sure that the building operates the way it was designed. And there are some real difficulties that I personally don't think we're going to overcome as far as getting full commissioning into the codes. I mean, it's not a black and white thing. It's very hard to write it prescriptively. It takes a lot of judgment and a lot of experience. However, we can move towards a lot of black and white things that we can do. So California, for example, has acceptance testing. People are talking about putting blower doors and duct blasters. There is no reason in the world that you can't get people to test lighting controls. You want daylighting? You want to claim energy savings for daylighting? You better make sure the controls work. You know they don't in 90% of the buildings now. I have the data that shows they don't. So we got to make sure that that's all happening, or we're not going to get the kind of savings we want. This is just to make the point. California did a small commercial HVAC survey. These were relatively new buildings. They were testing to see if they needed this acceptance testing. 64% of the economizers failed, 30% were running the fans when the building was unoccupied. Those of you who have ever gone to the National Conference on Building Commissioning, you know, there's just hundreds, thousands of examples of this stuff. So we got to deal with it. The way codes are set up right now is not getting us buildings that actually perform well. On the other hand, it's not a panacea. It still isn't going to tell you how this stuff actually operates once the building is occupied, but at least it's better than nothing. It's a huge step forward from nothing. Something to keep in mind, if we go this direction, you got to start asking yourself what happens when the building fails. There was a big discussion on this in terms of blower doors for the 2012, because all of a sudden it's not, well, stupid, you don't have a piece of insulation in your building, go stick another one up. Okay, now you pass. It's like, okay, you're supposed to have 7 air changes an hour, you've got 10. Wow, you better, find some Kleenex to stuff in the corners or something. It can be a big deal. So we got to find some reasonable balance between encouraging people to build buildings that actually function correctly, not hammering them too hard when they fail, but making sure that there is enough stick there that they get better over time. It's a very tricky thing to do inside codes. All right, finally, testing and measurement. There's a real quality control issue here. The way most of the stuff is set up is the building owner pays to have the tests done. This is a problem. I'm paying you. You have no incentive to fail my building. In fact, if you do fail my building, I promise you, you will not be hired again. So what we need is a higher level. You need some sort of, either the building departments or the states, somebody has to set up an outside quality control level so that you can do spot checks. You know, this is like riding the bus. The fare inspector only comes on once every 6 months, but knowing that he's going to come on every 6 months keeps most people paying. So it's a requirement if we want to go this direction. All right, next. Building type specific codes. I'm not sure what people don't get about this. And I can go on. You know, a shoe store is not like a grocery store. A grocery store is not like a warehouse. A warehouse is not like a school. But we have one commercial energy code. A few things are split out, but mostly this is a one-size-fits-all code for buildings that are wildly different in pretty much every possible way. So I'm definitely proposing, in fact, the Northwest is going to be pushing this as we go ahead in these hopeful national discussions, to go to building-specific codes. How many do we need? Let's talk about grocery stores. Well, it would be nice to have a specific grocery store code because generally that 50% of the load is refrigeration, makes it totally different than any other commercial type of building. Lighting's another 20 or 30%. Do that. But a 7-Eleven is not the same thing as a Safeway or an Albertsons, whatever regional chain you have. And that's not the same thing as a full-size grocery store inside a Walmart or a Costco. So you need 3, maybe even 4, just for grocery stores. Schools. I'm sorry, but an elementary school acts nothing like a high school. You don't have the gym. You don't have a possible swimming pool. You don't have an auditorium. So you can't look at these the same from an energy perspective. I believe in order to do this right, you'd need 30 to 40 separate codes. Here's your possible reaction. Are you out of your mind? 30 codes, it's impossible. The building officials will kill you. You can't do that kind of stuff. It's insanity. Oh, please. We're talking about code development here. It is critical that the end user has a simple tool to deal with. It is not critical that the development, the black box on the other side, is simple. So all of you who are in the code development process, it's like, suck it up. We're going to do 30 or 40 codes, and what happens at the end? The guy who needs to build a grocery store pulls out a 6 or 8 page code, and 90% of it is relevant to the building they're building. Right now, they pull out a much larger code, and 90% of the stuff is not relevant. So from an end user perspective, this is much more easy. It is much easier to enforce from a building official perspective. This is the way to go. One of the beautiful things about it is you can do it incrementally. So let's say, we've only got time to do the grocery stores one. So in the scope, at the beginning of the commercial section, you just write, this applies to everything except grocery stores. If you're building a grocery store, see appendix, GROECERY. And you go there, and then you could just add them, over time. It could take 3 or 4 cycles to build them all up. But at the end, you've got something that's way easier to deal with, and then you can tailor it. The whole point of this is, if you can fix on the stuff that's important in each building type, you can crank this down. You can keep it prescriptive. You can keep it simple, and you can get way more than 30% savings. That's why this is important. All right. Problem with it, yes, mixed-use buildings. I don't have an answer. You got to deal with it. So if somebody smart, figure it out. We did a survey recently on commercial buildings, and mixed use is a large chunk of it. It's half the buildings are mixed use in one way or another. So there may be some combinations like, I don't know, retail on the bottom and residential multifamily on the top. Maybe that covers a big chunk of it. But there's a bunch of weirdos too, I don't know, mechanic on the bottom and something grocery store on the top. So we can figure it out. All right, consumption limits. Those of you who were here last year heard Todd Taylor give an eloquent speech about how you save energy. You just limit the box, right? You got 80 amps or whatever it is, do whatever you want. As long as you don't use more than that, save lots of energy. You could also do kWh. There's actually something called it's the 2000 kWh Society. It's like, this is your share. Here's your bucket of kWh. Have fun, use it. When it's gone, it's gone. You don't get any more. In part, this appeals to me. I mean, it's simple, I'll tell you that. There's no arguing about it. You get this much, or you get, a limit. When you're done with the limit, you're done. The more I've thought about it, the more problems I have with it. Practically speaking, I'm living in a house. There's 2 people. I'm living in the same house. There's 8 people. There should be a difference in the amount you're allowed. You're running a commercial building from 9 to 5. You're running the same commercial building from 6 in the morning till 10 at night. You should get more energy. I think you can deal with all those things initially. That's not a problem. You could come up with some formulas or algorithms, say, okay, you're in this situation. The thing where I think it just goes off the tracks completely is somebody would have to be in charge of changing it every single time there was a change that justified a change in energy use. And, this is Big Brother material. Who's going to notify your utility or your building department? Hi, my son's home from college for the summer. Can you give me another 300 kWh, please? So I do like it in theory. I just don't get it, how it would work in practice. Final thoughts before I jump on to enforcement. Prescriptive is good. Simple is good. We want to keep expanding, do stuff, but if you want compliance, which is where this is all going now because of the, I want to say era, and now that guy messed up my head because I'm not allowed to say, what am I supposed to say now? Recovery Act. If we're going towards compliance, you got to make this simple for the building officials and the builders. You're not going to get there, or you're not going to be able to prove it, one or the other. So now, I just turned to the wrong page. So enforcement, like I just said, it's just a piece of paper unless you achieve high levels of compliance. And as I said in the very beginning, the current regulatory structure probably does not work if you're serious about energy savings. Building officials have a lot of things to do. Energy is just one of them. And bluntly, so I've been working in energy for 20 years, they've got more important things to do than the energy code. I prefer to use a little more energy and not have the building fall on my head or be burned in a fire. So if we're going to keep moving towards larger scope codes, more sophisticated codes, sophistication means specialization. And I've got no problem keeping that inside a building department, but I want a dedicated energy code professional at that point. I don't want somebody who just happens to do it as part of 10,000 other things they're doing. John Hogan is sitting right here, a living example that this can be done. He is an energy code specialist at the city of Seattle. They've been funding that position for a long time. So it's not that radical a concept. Clearly, it works in large jurisdictions because you can have an FTE. For smaller jurisdictions, you'll have to have some sort of, circuit right or some sort of shared arrangement, but you can do it. If you don't want to do that, we could go to some sort of third party and a certification thing. Again, this is nothing radical. Seismic inspectors sign off on things and hand it to the building officials. Lots of other special inspectors do it. You just basically farm out the energy code. Whoever's in charge, who's been certified, writes their name on it, says, yes, your building passes code, go. Again, this has been done before. And I think we're going to have to go there, or some version of this. Another one, it's kind of more interesting, is make the utilities the building energy code department. Why? Well, think about it. If we're really talking about zero energy buildings, like if that's where you want to go, and I'm not saying we do, I actually don't think we should go there in the near term, but if that's where you want to go, whoa, enforcement's easy. You got a meter, it's got 3 things on it. Energy used, energy produced through renewables, difference between the two. If it's positive, you pay a $10,000 fine. If it's negative, you win. You're done. There is no enforcement, or you turn them off if it's positive. So my point is there's a variety of ways to deal with this, but system, or whatever you call it, business as usual is not going to work. So we're going to have to get beyond there. Last thing I'm going to say, back to that table I had with all the determinants of building energy use. We're trying to save energy. Energy gets used over the life of a building. Doing a pre-occupancy test and handing somebody a certificate of occupancy, I mean, you want to do it. There's nothing wrong with it, but it's not remotely getting you where you want to get. So we've got to go to annual inspections. We've got to have some way to deal with maintenance. And again, this is not radical. If you work in a commercial building that's more than a few stories, you have an elevator inspector that's going in there pretty much every year. You have fire inspectors that are in there all the time. It's not a big change, but it is mentally, because energy's always been this kind of, ugly stepsister problem, and nobody pays too much attention to it. I certainly hope that as a society we are getting more serious about energy use, and we want to start cutting it down. That's good, and in order to achieve that, we're going to have to start doing things a little differently. That is everything I had to say, and like I said, the only reason I was saying it all, these are my summary statements. Oh, you guys didn't see all these slides, but they're boring anyway, so don't worry about it. All right, this is where Sean comes up. This is just bullets of the 6 or 7 things that I was talking about. The question is, do you want to talk about these? Have you got better, different ideas? Anything's open. My personal preference is that I don't do a whole lot more talking right now. I just got handed the mic, and I appreciate that, but I'm done, and this is, like I said, hopefully the first of many national level discussions on where we should be going with energy codes. So with that, Sean, take over.
Okay, Dave, stay. Okay. All right, so now it becomes a dialogue. Dave had some, I would say, pretty provocative statements there about what do we do once we get to 30 to essentially push the envelope further towards higher levels of efficiency and zero energy. And so he offered up a series of things. He actually started with policy, but policy and then increase the scope of regulation, testing and measurement, building specific codes, consumption limits, dedicated energy specialists, certified third-party energy code plan reviewers, and then using the utilities as code enforcers. So what has he missed? Why don't we start with that? Has he missed anything? There are microphones at the front here. There's also a couple walking mics that can be handed to people. Go ahead, sir. What has he missed?
Thanks. I'm Mike Barsick from South Face in Atlanta. I liked a lot of what you said, Dave. I think the thing that you sort of touched on, but that to me helps us get to another level, and I don't think it necessarily adds a whole lot of cost. I liked your curve, and I agree with it, but I think there's a missing thing, and I'll go back to, I don't own a Prius, but I wish I did. I get to drive one sometimes, and what is it about the Prius that makes me get really good gas mileage? Is it the hybrid engine? Is it the regenerative braking? It's actually the dashboard. So what I think we're missing, and what I think future versions of code need, is the consumption meter inside the house, right next to the thermostat, and I think it needs to measure energy consumption as well as dollars. So that's my $1 million idea, which I did not invent and borrowed from others, but I think that needs to be in the code. That's, I think, the next step.
It's a consumer, a feedback directly to the consumer in real time. Over here.
going back to what this gentleman was saying is, Microsoft, for example, is developing an application that allows you to do energy monitoring for residential applications. In that line, if you're looking at your power bill on real time, you're more self-aware of what's going on. But that was not my missing point. Is if it worked for Coca-Cola and it works for McDonald's, we need to do this marketing. People we're seeing as the ugly stepsister or whatever, because people are not aware. The reason why Energy Star has acquired so much penetration in the market is its branding, public recognition due to image and sustained performance over the years. So that if we do something like that on reaching the public at different levels throughout the media, then we would get further.
Okay, so there's two versions of consumer awareness there. One is the meter inside the house, and the other...
Move this down a little bit. The other is essentially marketing, making people more aware. Let's go over to this side.
I think that we've been riding the same design horse since the energy crisis first developed in 1973. That literally what happens is that we've been trying to beat more and more and carry more and more with the same types of construction that we have always done, that we have passed on from generation to generation, and that literally the people that are working in building science right now are looking at how do we actually change the tapes? How do we change the way that we construct buildings so that we can get to places like zero net energy? And it is involved with the people, the whole design community, and it's involved with the whole construction community. You've got to get people educated into changing the way that they actually do things. If you want to take and, for instance, and get a heating system that is going to work and work as effectively as possible, the stuff that works is now condensing boilers. And if you try to run a condensing boiler at 180 degrees, it's almost impossible for it to work. So you got people now that are designing systems around water heaters. And a water heater works better as far as a condensing system. That's just one example. In the construction, we finally got the duct guys to realize that maybe it'd be a good idea to be able to tape the joints of the systems that they're putting in. And that's in some jurisdictions and maybe not in all. So that there's a whole learning curve that has to take place if we're going to take and literally make a quantum jump.
Okay, so I think what I heard you say was education and training, but even beyond that, we have to rethink the way we're building the buildings as well. Transfer that knowledge.
We're still taking and building houses on plans that were in plan sets that the builder bought 20 and 30 years ago.
Over here, please.
Hi, Dave Hewitt from New Buildings Institute. I'll do three sort of linked ideas. One is I think another approach to add to your four, David, would be the idea of using more of a, I would say, a systems approach to looking at the building. So again, Mark, we come at this mainly from a commercial side, so this might be different on residential. But start setting perhaps limits on what you want to do with lighting, limits on what's going into the HVAC, limits on what's going into plug loads, limits on exterior lighting. And then that means you're going to have to be in metering the building differently, and I think some of that's already starting. Related to that is an enforcement mechanism, is to shift to the second idea, is that one of the enforcement mechanisms could be utility rate structures. That is, we could decide that there is a reasonable amount of energy that a building should consume. It's already built, it's in operation. We want to enhance the operations and maintenance of that building and how the tenants use that building. A rate signal might work. It wouldn't penalize everybody in society like perhaps a carbon tax would, but you could say, as we do with gas guzzler taxes on cars, or as we do with lifeline rates to protect low-income people, you get X amount of energy for your lighting system, and if you go over that, you can get it. You just need to pay more, and that more can buy carbon somewhere else in the local economy. The third idea, I think, relates to what the other speaker just said, is if we do this and we sort of squeeze systems, I think we can encourage innovation on the design side. And so we're seeing some of the lowest energy commercial buildings have very advanced mechanical systems, frequently ground source heat pumps. They also have simple natural ventilation strategies, like operable windows with a signal that goes to a computer or a red-green light on the wall. And they have good buildings, they have good shelves, they have good other things. But we can encourage innovation in terms of how we approach lighting by using, a daylit facade and appropriate controls, or HVAC by using natural ventilation strategies or other sorts of advanced mechanical. And I like the idea of encouraging innovation and bringing more design elements into this. That might be more difficult to enforce, but again, if we do this on a systems basis, the enforcement mechanism could end up being rate structures. Thank you.
Okay, so systems integration was the first one. The a tiered rate structure with something like the lifeline for utilities. And the third one was, as you drop the systems integration approach, you're getting more innovation in the building construction.
I believe you mentioned building energy performance standard in your presentation, but sort of dismissed it and didn't include it on the list. Those of us who are around here in the 80s remember the proposal for the BEPS, and with RIFs and RUFs and all the other fun stuff, building energy performance standards, which failed miserably. However, I do understand that Europe, I don't know much about it, but I've heard people say that Europe has building energy performance standards and they seem to be working pretty well. So I think it would be worthy of, rather than embarking on a whole research project to figure out what ours should be, just to look at Europe and does it work, why does it work, what can we learn?
Okay, so a little learning from our neighbors.
Harry Mazzarello, ACEEE. I think one of the things that could be added is some notion of harnessing market forces here. I mean, this is heavy-handed regulation all around, and possibly there's price elasticities that can be exploited, as Dave was mentioning. Maybe change the rate blocks a bit so it gets very, very expensive to use that next block of energy. Certainly at the construction phase and real estate transaction, there's the move toward disclosure of building energy performance. The simple way using Energy Star and the more comprehensive approach on energy efficiency features that's in the ASHRAE EQ approach, but something along those lines that actually make the real estate market more transparent and put a higher value on energy efficiency, higher than it has today. So I think that these are certainly good ideas, but I think our culture, our particular unique American culture, demands some type of exploitation of market forces to get there. So we ought to seriously consider what we can do outside the regulatory system to get at that. But that also presupposes that this becomes a higher level issue to the average American. And certainly national energy security might rank very, very high. So maybe we have patriotic buildings or something that enhance America's energy security and make us more competitive. So anyways, these are just some thoughts there, but certainly our culture will be expecting some type of market incentive. Maybe real estate taxes. You tax the energy hogs a lot higher than you do the ones that are more environmentally benign. So I think some combination of those things would certainly move this along. Thank you.
Okay, so was getting a market response through costs, and perhaps not only just taking that meter and throwing it on the inside of the house, but making it aware on the MLS listing, or outing buildings that are using a lot of energy. I'll give you a perverse example. I saw one time somebody said the reason they bought a Hummer was to support, partially was to show their support for the troops, and I could never figure that one out.
Yeah, I'm Todd Sears from Evergreen Power Systems. I'm a builder, so I come at it with a little bit different perspective. But I guess the keynote here for me would be innovation. Just to capitalize off of what Heath said, various different structures like LEED, et cetera, have innovation and design credits. And in 2010, they finally start to allow for daylighting concerns to get some kind of payback, so to speak. So if you want to capitalize on the market forces, in addition to tax credits, et cetera, you've got to figure out some way to make the code where innovation from the field and the market and these other silos happen as you go. Because as a building is built, you never have a better example of when it will happen than the building itself. For example, if we have a high-profile client like AT&T or Google, we will certainly try more things with that kind of scenario where there's marketability or we're going to get something out of it than you will get from, just a prescriptive smaller building or office structure. So if you don't put something in there to make that feasibility, you're never going to see whether it worked or not. And most of our stuff where we're seeing and we're gaining and we're learning and we're using the latest stuff from Lightfair and we're squeezing those systems like you guys are looking for is driven by things like LEED and marketability where we're seeing a payback for it. We're willing to do it. The customer's willing to do it. And we're making a huge trend into BIM and to O&M, which is, I think, half of the situation here. If you don't get it over the life of the building and you do it all in the pre-occupancy, it's not gonna happen.
So are you a residential or commercial builder?
We're commercial.
Commercial builder. Okay, so the idea then is you want what you're doing to be valued in the marketplace. Is that what
innovation credits in the code? Like LEED, for example, has innovation. You can only get 4 points. It's not a lot. It's not going to make or break you, but it's something. And if you can show something, $10,000 for this point, you'll get it because there's something for something to the owners. Everything has to drive back. Everything here, code-wise and down, if you don't drive it back to the owners, it isn't really going to happen. So, I mean, the difficulty I see, especially with the gentleman who was here before me that wanted to talk about a significant change to the system, is nobody wants to do that in the building code side. The building codes inspectors and the people within the municipalities, there's huge risk. Risk is one of the biggest factors in a business, and they're not going to want to do things that are risky. But you have a little bit more flexibility in the energy code because we are the stepsister, or however you want to put it. They're also not as timid about letting us trade off. You don't get to trade off a certain amount of ventilation you have for a person in a space, whereas you can with energy code. So I think we should take advantage of that. So innovation in the code.
Innovation in the code. Sir?
Hi, I'm Doug Dean. I'm a consulting engineer. Just like the person from ASHRAE said, we don't work on residences, but what I want to talk about is residences. As a homeowner, I'm reluctant to put a lot of money into my house that would have a payback of maybe a number of years, because I don't know how many more years I'm going to live in that house. And recently I was looking to buy another house, and I had a heck of a time trying to find out. One of the things I was interested in is what kind of energy use history the house had, because I was thinking I would be living in that house. And I had a heck of a time getting that information. The utility information, from what I understood, is not available to anybody but the owner. And when I asked the people that were living in the house about it, they says, oh, we've been burning wood in our house, which made me think that maybe they were having real expensive heating bills before that. Some way to pass the information on to prospective buyers would make people more willing to invest the money in their house now, because it passes the way to prove that it passes on to the next person. And that would make, without any regulation, that would just make people more willing to put the money into their house now. But it would have to be something that, like you talked about on the MLS statements, I think that's what the real estate agents give you.
Multiple listing service.
Yeah. if somehow people had to give the past year's utility bills and evidence of what they did to make those bills go down at some point, that would go a long ways to making that transparent to the market.
All right, so you said two things. One was hearkening back to what somebody else said about essentially when a house is transferred or a building is transferred, better insight into what the current energy usage is, the historical energy usage. But the first thing you said was that in the current way we buy and sell homes, that if your investment has a payback period beyond what you're comfortable with, and that might be 3 to 5 years, you're not sure when you'll sell this home, you won't make that investment. So if there's a way to amortize that or and transfer it with a curb assessment or the utility owned it or something, you'd be much more willing to make that investment. Over here, please.
I haven't been in this business for very long, but a couple of years ago when I started, I did a bunch of stump speeching through Massachusetts, educating folks on the new energy provisions for the state. And the one message I gave them at the end of the talk was, pay attention to the energy stuff because it's going to be a big deal sooner than later. And all I remember getting back at that time was about 1,000 blank stares because it wasn't their focus, as David said, and hasn't been. So what I would suggest is that we take, if we have at the federal level, plans, Habitat for Humanity plans on net zero buildings or whatever, and try to get them out there so that builders can use them that maybe are not Energy Star builders.
Okay, so the plans, the existing plans for successful low energy or zero energy usage buildings, getting those more widely disseminated to builders. Over here, please.
Howard Wigg, State of Hawaii. Encourage distributed generation. Install a very, very clean burning diesel plant on site to supply very high grade electricity to the facility with 0 line losses. Run water around the diesel plant, make steam, divert the steam to the laundry. You still have very, very hot water left over, divert that to the kitchen. You still have hot water left over, divert that to the faucets and showers. You still have some heat left over, put that in the swimming pools. You move from 33% generation efficiency to 85-90% efficiency.
Okay, I'm going to take that. I'm going to just generalize it a little bit by saying that what you're talking about is thinking about buildings in a systems integration way. So you're thinking about how to optimize energy use or minimize energy losses between several buildings, not just optimizing each building individually. Over here, please.
Yeah, hello, Chuck Murray. I think in order to move forward in codes, we need to re-examine our inclination to pitch these things as cost-effective, lowest cost, not sure how to say it, that every next item you put in your house, you're going to get more benefit than cost. I want to remind you of the slide that Tom Ekman showed you at lunch where he saw that we actually saw declining energy prices that were the result of energy conservation. We're at the point in Washington State where many houses use $300 worth of fuel a year. Is a consumer really going to react to a change in behavior to knock $20 off their annual bill? We're doing this for other reasons. We're doing it for carbon reduction measures. If you want to play the cost effectiveness card, what you're asking for is an artificial increase in carbon cost in order to support your building codes. So we're doing the building codes in order to avoid those costs. I'm sure I'm not exactly being clear here, but I think people get the idea.
All right, I'll try to be clear. I heard a couple things. I heard you say that we're doing these things not for reasons of saving some money, but for saving some carbon, perhaps, and a greater good. So perhaps what you're talking about is something I haven't heard thus far, is an ethos, establishing an ethos, if there's no carbon tax, for people to consider energy use in buildings as from an ethical standpoint. Just as there's no cost to me personally, unless I'm caught throwing something out the window of my car. Yet most of us don't throw the trash out the window of the car, at least we don't anymore, and everything looks much nicer along our roadways. Over to my right.
Isaac Elnicave, Northeast Energy Efficiency Partnerships. I wanted to start from a very useful thing that David said as a reminder that really what we're trying to do is ultimately save energy. That's kind of the mantra that I took from what he was saying. And in that respect, we have to start thinking beyond just the typical codes that we've looked at in terms of new buildings, and we really need to start thinking about how codes would affect existing buildings and how we can establish and what kind of structure, whether regulatory or market-based, would get at requiring or getting improvements in existing buildings across the country. From a kind of a math perspective, even if you go to a net zero energy building code on new buildings, you will probably not do as well as getting a lesser improvements on existing buildings. I come from the Northeast, and we have the prototypical very, very leaky buildings, and so improvements there will get you huge savings without even getting to net zero energy. So I think the whole point is, how would codes be able to deal with existing buildings, and how can we make that happen?
Okay, extending codes to existing buildings. I think Dave was trying to touch on that a little bit with the testing and measuring. What jumped into my head was I have to take my car in for an emissions test every 2 years, and if I fail, I have to do something, which could be a tune-up. Or I may have to take it off the road if I don't get it straightened out.
The whole point is not just the testing and the measurement, but having that tie into some type of action.
All right, tying the testing and measurement into a positive action.
John Hogan, the City of Seattle. Sean, you very much took to heart David's slide here, which finished with this big, bold question about what else, but I'm going to suggest that we go back and focus on the main topics here. This is not the National Marketers Association meeting, not the National Utility Association. It's the State Building Energy Code Conference. I think we're missing taking advantage of the expertise in this room by having people talk about other things and not sharing what expertise they have about building energy codes. So I would suggest that we work with the ICC format, and if people don't address the topics up here, then you rule them out of order. And so we can stay focused on what's going on here.
Well, one of the topics was what else, and I wanted to make sure that we covered the waterfront.
Yeah, I think you did a good job of that.
Okay, so you're up there.
So just touching on a couple of points, increasing the scope of regulation. I think certainly it's important to move into other areas that haven't been covered. I think people always talk about plug loads. There's more process loads in some documents than people realize already. ASHRAE 90.1 addresses fume hoods, which in laboratories you could certainly call that a process. 90.1 requires that if you have a hospital, you have to recover condenser water heat to preheat the water you'd use for the laundry, so that would also be a process. Covers snow melting systems. So there's a number of process things that are already covered, some at least in standard 90.1, and certainly that could be expanded. So I think that's a good idea to continue doing that. Building type specific codes. You nuanced this a little bit, David, but I think there's some challenges here between what the scope is of the code development agency and all the work they do in the background versus what shows up for people to deal with. And I think the codes already have this to some extent. So if you're doing lighting, there isn't a lighting budget for any building. You have to go into the table. You have to pick out your building area. So there's actually not a building number. There's an building area number. So if you have office on those floors and retail here and restaurants, you pick out all the different lighting power allowances. Mechanical is not so much that way. It's different mechanical system. Pick whatever one you choose. Doing that for building envelope, I think, is more of a challenge. I think there's so many changes of use that if, I think of a building in downtown Seattle, so it's got a restaurant, and it's got dry cleaners, and it's got a travel agency, it's got some retail store. These are all on the first floor. They're all, 30-foot storefronts next to each other. Are you going to set different envelope requirements for each of those storefronts, which are right next to each other? So I don't think that's so valuable to do that. I would take Mark Halverson's provocative comment that didn't draw much discussion this morning about starting with a fixed number like a BEPS number and then developing criteria. I think you could do that with supermarkets or something, and that would limit the mechanical systems you could choose from. So you could say, okay, you're allowed 40,000 BTUs per square foot per year. Okay, we've got your lighting budget. That's been in the codes for a while. Maybe we lower that a little bit. But we're going to limit the mechanical systems to one of these, and here is sort of a standard envelope. So I think there could be ways to go about doing that. But certainly don't put them all in as prescriptive requirements in the code. Use them for development, but don't put them all in separately like that.
Thank you very much. Someone else like to speak to the first items that Dave put up?
Paul Cheetah from the state of Montana. Rather than utilities being code enforcers, as utilities being partners in building more energy efficient buildings. I got involved, started with energy in Montana with the Super Good Sense program. Thousands of homes built to 49 attics, 26 walls, 19 basements, because the builders were receiving $3,000 from Sponsor 2 Bonneville. Bringing those programs back. I don't know if anybody can address, but Tucson Electric has a program, their Guaranteed Energy Bill program, where they make 3 inspections of the home. They guarantee the bill in that building, and for the life of the home, it's a 12% reduction in the utility rate. That's put into the base, so having programs that are in the base that spread among all the customers to make improvements in new construction. Does anybody have any information about what Tucson Electric? They should be at this conference, I think. But for the life of the home, if a builder signs up, the home gets a 12% reduction in their electric rate. Great program.
Thank you.
I wanted to address the building type specific codes, and I just think about the ASHRAE 30% guides for the 5 or 6 different specific building types, and I wonder if somebody at ASHRAE maybe had that in the back of their mind, that this may be the direction. Of course, those guidelines go way beyond code, but I think people should take a careful look at how that's going. Hopefully, evaluations will come forth, and that could be the genesis of, say for a hospital, which has got lots of special uses and that sort of thing. That might be something that would evolve into a building-specific type code.
Over to my right.
This is Miguel Quiñones, Virgin Islands Energy Office again. Well, starting with the building type specific codes, as we have talked about, the initial energy reduction is cheaper, therefore you have to come with novel ideas. And in order to achieve out-of-the-box ideas addressing each specific building type, you cannot follow the same rules, because everything from the shell to the mechanical equipment that you use for different purposes can be optimized. And when we're talking about the system integration, we're talking about renewable energy implementation, everything tailored throughout the systems approach for a use. And there you get the maximum savings on each specific building. On top of that, as far as the actual code enforcement, when David was talking about listing each specific building type on an enforcement checklist or a documentation for people just to follow a single document instead of doing multiple references and so forth, I think that if the engineers stretch out a little bit out of their comfort zone, and instead of doing all this mathematical number crunching computer spreadsheet system into a more flowchart kind of thing, maybe with computer IT experts, people that are more qualified in doing flowchart approaches, you can simplify the actual code development process. And that would save a lot of back and forth discussions on different items, because you can do a flow chart on different levels, and then you would just discuss a level at the flow chart instead of having to do the whole thing. I mean, you do a sequence, and it's a sequence of procedures in order to commission a building, and then you can do the development process is based upon that sequence and not all of the code. There was something else I had to say. Well, I'll leave it at that.
Thank you very much. Anyone else? Go ahead.
So I'm wondering if I can get some people to come up and react to some of the things that have been said. Remember the IECC hearing, we need the rebuttal, sur-rebuttal, all that sort of stuff. One thing Chuck Murray talked about is basically throwing cost effectiveness out of the arguments for energy codes. I mean, that's a pretty big comment. And I actually didn't hear it quite the way you did, Sean, as an ethical thing, as much as it's a cost-benefit analysis, making sure that you've got the right benefits and the right costs. So if there's societal costs, it almost goes back to what I was saying about the US DOE appliance standards hearings. If you've got lots of benefits on one side and a small amount of costs on the other, you don't not do it. You just make sure that the equation is right so that they're all captured. But I mean, I would love to hear, especially some builders, talk about why we should or shouldn't have cost effectiveness as part of the calculation. That's huge. The first guy who came up talked about the energy monitors. I own a Prius. Sorry that you don't, whoever you are. But I don't get better mileage because of that little thing. I get better mileage because if I drive it exactly the same way I drive another car, it gets 3 times better mileage. So I have heard a lot of conflicting comments on the value of providing that level of information to consumers. I'd love to hear anybody who's got thoughts or is directly involved with it. I'll just stop with those, but I think there's a couple other things. If anybody had ideas on anything that anybody said, for or against, it would be great to hear it.
Any comments for or against, or responding to any of the other commenters?
And what do I have to do about you modelers that nobody's going to come up and defend yourselves? I mean, geez.
Over here,
please. Hi, my name is Adrienne Tomley. I'm with Honeywell. I've got 2 comments. The first one on the cost. Being a manufacturer and working with contractors, and maybe our contractor friends would like to add to this, what I hear all the time is we will do the minimum we have to do to meet the code, but it has to be low cost, because they're always going on bids for jobs. The second comment I have is I'm on the steering committee for ASHRAE for the Advanced Design Guidelines, Energy Design Guidelines. And we are going to be doing a survey in the next year asking the community how you use Advanced Design Guidelines and how they can be improved. And so I'm encouraging you, when you see that survey, please fill it out, because the more information we get back, the better we can make those design guidelines and do it how you want. And the ones that you want written instead of the ones that we perceive have to be written. Thank you.
Yes, sir.
I'm Todd Steers, builder. I'd answer your question about whether that feedback is useful. I think it is to companies. I think it is to people that have a vested legacy in a 15 or 20-year building. We're being seen and asked that kind of question a lot, where they can see the payback. Once again, I want to reemphasize, my other comment was innovation or trade-offs make it worthwhile, is that once again, it's not the contractors, the builders, and the manufacturers lots of times who we need to be focusing on if you want to move away from where we've been. We need to focus on the owners, because it's the building life of the building, and what do they say, 10%? I mean, I've heard a lot of different studies on how much is in the prescriptive phase. So if you're going to write these codes, they need to be written. And so to answer to your second question about the cost benefits, should we move away from cost benefits? Just say it's society. Just say it's energy. Just say it's. Well, sure, you can move those ways, and you can do tax incentives, and you can do rebates, and you can do et cetera. But I think a better route would be to move away from how much it is initial costs and really drive towards whole cost of ownership, which can include performance, which can include performance of employees. It can include, there's 4 or 5 different standards out there that are marketability. I think I heard somebody said they had a lead AP here that bring in other factors. So if you want to have the energy code be effective at selling things that don't make sense cost-wise, let's say I'm only saving $20, but I'm still saving energy. If you can bundle it with some other performance advantage, even though your role as a building code creation person is not really to address those other issues, you've just sold a really expensive energy piece of savings because you tied it to something else. So even though the person may not want to save 20 bucks worth of energy code, if they save 20 bucks but don't have to haul the wood in the house anymore, you've just sold that. So,
thank you.
Tom Zaremba, and I wanted to respond a little bit because to the cost effectiveness argument. I philosophically agree completely with Chuck's comment, particularly, I guess, more so in light of the weatherization program that DOE is really starting to expand, for the reason that you've got a huge discrepancy between existing homes with monolithic glass and no insulation and trying to market new homes that have, built-in compliance with energy codes. The further you reach into the existing building stock with the weatherization program, the easier it is to say, we're all working toward this common good. It's a little tough to say that to a person who's buying a home, paying a premium for energy compliance when, there's 3,000 homes in the same greater urban area that have no insulation and have windows that are 40 or 50 years old. In addition to which, on that particular point of the existing building stock, I've got some daughters who are trying to take advantage of the home purchase credit. And I can not tell you how quickly the price comes down as soon as you not only include a building inspection, but an energy audit for the house. So that helps a lot.
Thank you very much. Please.
My name is Mark Liberty. I have the pleasure of speaking with you all tomorrow. I just want to bring a couple things. Bruce Nelson, it's really nice to see you. What an amazing fellow he is. A couple quick things about the cost. The gentleman who said $300 a year for energy bills. I don't think so. Okay. So here's the catch. How long do we believe buildings should last? What's a fair lifespan?
Residential or commercial?
Yeah, there's an interesting balance here. In the U.S., the idea is different than it happens to be in other parts of the world, right? So we make buildings that should last maybe 75 to 100 years, where the rest of the world believes hundreds of years. The life cycle issues about the choices that we're going to make today are essential to the future generations that you are all responsible for. So the idea about how do we make energy improvements and durability of buildings in health and safety and combustion safety and efficiency of structures is what we do today. That is our job. And if our calling comes down to nothing more than, is there a 3-year return on investment, we missed it, didn't we? The longevity of buildings and the impact of what it is that we do is our responsibility. To look at energy costs as the sole reason to do things is the wrong approach. The variability in energy costs and its contribution to carbon and offsets has everything to do with the fact that we are supposed to, as societally, making those impacts and those decisions based on the importance of what we do for the future. My children are depending on me to make good decisions today. We all know what those are. And in the future, we're going to have to decide, was the fact that we made a decision about the return on investment being good for 3 years and that was it? That's a sad day, isn't it? So I think all of us can say that the opportunity here is to create a way of looking at buildings and how we holistically deal with safety, health, durability, efficiency, and performance in a much better comprehensive approach. And I think that we can do that instead of worrying about the little incremental pieces. We know as a society and as a group of engineers and professionals, we know how to make efficient buildings work. Is that true? Air tightness, thermal insulation, high performance windows, proper ventilation, energy recovery. We know how to do this. Our obstacle is just attitude. That's it. Just choose to do that. Is that fair? No?
Thank you. I don't see any other speakers. Mr. Cohen, do you want to wrap it up? You threw up a list of ideas. You heard a bunch of ideas, some variation on theme. I'll throw out one, which was somebody made the comment about energy. What brings down the price of a home is an energy inspection as well as a home inspection. What about a role for energy codes at that transaction when you sell the home? Does something have to come up to at least part of the code?
That's a fine idea, Sean. So the wrap-up is just that we are already thinking about this in the Northwest. We've had a few preliminary discussions. We will continue to do so, and we will be forcing, as much as we can force from our little corner of the woods up here, these issues to continue to be discussed in a bigger and bigger way nationally. We will bring some straw men out. We'll engage with DOE and PNNL and try and get this stuff to happen. I think I just want to emphasize that we're almost done with the 2012 cycle. Okay, it's going to take another year, but the proposals are in. And so it's time to start thinking about this stuff now, because we only have another 3 years. And if we really start changing, like I said, the basic structure of what we're doing, 3 years is not a long time. So I look forward to engaging with all of you over the next couple years, and I hope you will bring your best ideas and thoughts and people to discussions, and I hope that Gene will fund PNNL to make sure that these discussions happen. Just a little pitch there. Thank you all for coming.
Thank you very much, and a round of applause for David.